Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 4. Why do banks pay you to provide their services? So example 1 says, Kira has been babysitting since 6th grade. She has saved $1,000 and wants to open an account at the bank so that she earns interest on her savings. Simple Bank pays simple interest at a rate of 10%. Yeah, I wish. How much money will Kira have after 1 year, after 2 years, if she does not add money to her account, and then again after 5 years? Okay, so question being, why do banks pay you to provide their services? So they say, okay, we have this bank. If you bring us your money and put it in our bank, we will pay you. Well, the reason they pay you is because if a lot of people bring money to the bank, a lot of money accumulates, and then the banks take that money and invest it in other companies in the stock market. And so if they buy 1 million shares of, say, I don't know, Facebook, and Facebook's share value goes up $1, then they made $1 million on that $1 rise in that share value. So they take your money, they invest it, they profit hopefully off of it, and then they sell their shares at a higher value, making money. So then they give you a tiny little percentage of that, and that is where the interest comes from. So they're giving you a portion of interest for the amount of money that they're making. Okay, so here's this Kira, and she's been babysitting. She saves $1,000. All right, so what is the equation? I equals PRT, okay, from a couple lessons back. So that's the equation. And remember what we always do. We say what I equals, and we say what P equals, and we say what R equals, and we see what T equals. Okay, so I is the amount of money we have after time has gone by with interest accumulated. So that's what we're trying to find. Our principal value is 1,000. Our interest rate is 10%, which is 0.1, which is unheard of. That would be crazy. I'd have all my money in the bank right now making tons of money. But that's not the case. Interest rates now, you'd be lucky to get a 0.5%. All right, and T. So let's do T equals 1 first. So we're doing the 1 year. So let me move this over because we have to do it 3 times. So here's the first one, and we're trying to find out how much money we will have after 1 year. So the principal amount was 1,000, the rate was 0.1, and the time is 1. So I equals 1,000 times 0.1, move the decimal place 1 place, that's 100. Well, 100 times 1 is just 100. So how much money will Kira have after 1 year? So after 1 year, she will have $1,000 principal plus $100 interest, which totals $1,100. That's after year 1. Okay, so here's year 1, here's year 2, and we're going to do it again. I equals P R T, and now our T is going to be 5, not 1. So I equals our principal, $1,000, times our rate, 10%, but now it's going to be times 2. Okay, I jumped ahead of myself here. This is a 2, not a 5. We'll do 5 after. So now we're doing 2. Let me do that on a different line. I don't want to make it look like 12. So now we're going to do T equals 2. So I equals, again, 1,000 times 10% is 100. And now we multiply it by how many years, which is 2. So the interest is going to equal 200. So after 2 years, it will be $1,000 plus 200, or $1,200. Okay, and now we're going to go after 5 years, so now t is going to equal 5. So if I equals principal times rate times time, so therefore I equals principal times rate, 10%, 0.1 times 5. So I equals 100 times 5. So I equals 500. So therefore we take our initial $1,000, we add 500 to it, and we end up with $1,500. Okay. Now let me go back and read this again. So it says she says simple bank pays simple interest at a rate of 10%. Okay, it doesn't say 10% per year, but if it was per year, these answers are not correct. And so if they annually compound it, what you would have to do is take this value after 1 year and move that up to here, and take 1,100 times 0.1 times 2 and get a value. And whatever that larger value is, then you bring that up and do 3, and then do 4, and then do 5, because you're going to get interest on the interest they've already paid you if you leave it in the bank, if that makes sense. Okay? But this way we're just doing simple interest at a rate of 10% over 5 years. So basically you're making $100 a year on a $1,000 investment. Now Raul needs $200 to start a snow cone stand for this hot summer. He borrows the money from the bank, and they charge 4% simple interest per year. How much will he owe if he waits 1 year to pay back the loan? If he waits 2 years, 3 years, 4 years, 5 years? Okay, so it's the same process as above. We have an I, we have an R, we have a P, we have a T. All right, so he needs $200 to start a snow cone stand for the summer. He needs 200. He doesn't have 200. He needs 200. Okay. Okay, so he's going to borrow $200 at a rate of 4%, which is 0.04, over a period of 1. Okay. So I'm going to introduce function notation this time. So it's I of t for some period of time. Interest over a certain period of time equals PRT. So in the first example, we're going to do 1. So I of 1 equals principal times rate times t. So I of 1, interest rate, or interest that they charge after a year, would be 4 times 2, which is 800. 4 times 200 is 800, but there's 2 decimal places, so I go like that, and so it's $8. So how much will he owe if he waits a year? It's going to be the initial 200 plus 8, or $208. Okay, now we're going to do that again. In this case, we're going to do I of 2, which equals 200 times 0.04 times 2. So I of 2 equals that 8 times 2 now. So I of 2 equals 16. So therefore it's 200 plus 16, or $216 after 2 years. Okay, I of 3 equals 200 times 0.04 times 3. So I of 3 is going to equal 8 times 3. So I of 3 equals 24. So we take the $200 plus the 24, and we get $224. And that's after 3 years. Okay. After 4 years, I'm just going to do it down here. After 4 years, this will be I of 4 equals 200 times 0.04 times 4. So that is going to equal eight times 4. So I of 4 equals $32. So if we take the initial borrowed money, 200 plus $32, we're going to owe $232. Okay. Not really liking these problems because it would be compounded annually, so we'd have to it would be more than this. It would be more than $4 a year or $8 a year. It'd compound. But anyhow, I'll continue. I of 5 is going to equal 200 times 0.04 times 5. So I of 5 is going to equal 8 times 5. So I of 5 is 40. So therefore we're going to take $200 that we borrowed plus the $40 interest, and we're going to owe the bank $240. Okay. So now it says, B says, write a formula for how much he will owe after T years. So that would be I of T, which equals our initial cost, 200, plus, see how we added 200 every time? So it's 200 plus this formula. 200 plus 200 times 0.04, and I'll move this in a moment, times T. All right, so let me move this down. So this is the answer to B. All it is this formula here that we found the interest, but then we added 200 every time, so all this formula is going to be, and I can't call it I now because it's not just the interest. Okay, so we can call it some variable, I don't know, A. A of T equals 200 plus 200 times 0.04 times the number of years or time. Okay, example 2 says, Jack has $500 to invest. So notice what I'm doing. The bank offers an interest rate of 6% compounded annually. Okay, how much money will Jack have after 1 year? All right, so we want to find the interest for 1 year. Okay, so we're going to use that new formula though. We're going to do A of T equals 500, our principal, plus 500 times R times T. So there's the formula we're going to use repeatedly. So now I'm going to substitute it in. So I will do the first one in green. So it's A of 1 equals 500 plus, well, 6 times 5 is 30 with 2 more zeros, but then I have 2 decimal places, so 6% of 500 is $30 times T, which is 1. So A of 1 is going to equal $530. Okay, now I want to use T of 2. So A of 2 is going to equal 500 plus 500 times 0.06 times 2. Okay, so that is going to be A of 2 equals 500 plus 30 times 2, A of 2 is going to equal 500 plus 60, or $560. I'll just do 2 steps in one there. Moving along, now I want to do A of 5. So now I want t equals 5. So A of 5 is going to equal 500 plus 500 times 0.06 times 5. So A of 5 will equal 500 plus 30 times 5. So A of 5 will be 30 times 5 is 150. 500 plus 150 is $650. Okay, and then finally, 10 years. So if t equaled 10, A of 10 equals 500 plus 500 times 0.06 times 10. So A of 10 is going to equal 500 plus 30 times 10. So A of 10 is going to equal 500 plus 300, which is $800. Okay, so now I'm going to explain to you that this isn't how it works. I've already mentioned it in this video, but now I'm going to show you, because A of 1 is correct. That would be $530. But A of 2 is not 500 plus 500.06. This would be A of 2 would equal A of 1 plus this. Okay? So what I'm saying is what we have to do is somehow come up with a way of taking what we got from our first year, and that's going to come over here. So at year 2, we're going to make 530 our first year, but then we'll have 530 in our account. So this would change to 30. So it'd be 530 plus 500 times 0.06. So we'd have to add these together before multiplying by 0.06. So it'd be 530 plus 500, which would be 1,000, or let me see. 530 plus, so now we have 530, so no, that's right. So now what we would have to do is just change this to 530 right here. So 530 plus 60 would be 590. Is that right? No. Okay. All right, so this part's right. Okay, so after 1 year, we made 530. That's correct. But then we're going to come over here and take this 530 and put it here. So A of 2 is going to be 530 plus 530 times 0.06. So our value is going to change here as well. So this is going to be 530. And then we're going to take 530 times 0.06, which is 6 times 0 is 0. 6 times 3 is 18. 6 times 5 is 30, plus 1 is 31. Okay, so let me fix that. So 530 times 0.06 is 6 times 0 is 0, 6 times 3 is 18, 6 times 5 is 30, plus 1 is 31, 2 decimal places. So it's 3180 times 2. And that will change this, because 3180 times 3180, so this would be 530 plus 63, 60. 2 times 0 is 0, 8 times 2 is 16, but that's not coming out right either, because we're not making 590. So we have to come up with a formula that'll make this true. Okay, so let's get rid of these because they aren't correct. The only one that is our actual first year. Okay, so 530 would be correct. but something is going on after that 530. Okay, so let's start talking about what's called compound interest. All right, so I'm going back to question 1, and I'm going to explain this. So notice that we did I equals PRT for 1 year, it was $100, so we made $1,100, and for year 2, we just multiplied by 2 and said, well, we made $1,200 over 2 years, but that's not the case. You would make $1,100 and put it here and then multiply 1,100 times 0.1 and so on. So let me erase all of this, and I'm going to show you something now. I'm going to explain where the formula comes from. There's a new formula. Okay, so here goes. If we were to have year 1, make that a little smaller. Here's year 1. We have $1,000. And let me label this up. So year 1, there's our P. Here's our interest rate. Here's our P. So what we're doing is taking our principal value plus the interest rate times the principal value and adding them together. And we got 1,000 times 1.1, which is $1,100. And if you look at your notes, that's what we achieved. Okay, but here's what's going to happen year 2. Okay, so just bear with me here, because if you understand this, it'll be a lot better. Okay, so here's year 2. So look what's happening. Year 2, we took this amount and we put it here. That is our new principal. Okay, so that's our new, let's call that new value, and I don't know. Yeah, let's just use n for new value. So this is our n, and p is our initial value, our previous value. How about that? Previous value, new value. Okay, so we take that $1,100 year 2, we multiply it by 0.1 times that same $1,100. Now we're putting in our new here. So it's $1,100 times 1.1, okay? And why is it 1.1? Because $1,100 is 100% of our initial value, or our previous value. That's all of this, 100%. So that's the 1. And then the 0.1 is this. So now we're taking the initial value, the P, times 1.1. Times 1.1 a second time. So we're taking this value, which is right here, and multiplying it by 1.1 again, and we get $1,210. So all we're doing is multiplying by multiples of 1.1. So if I take year 3 and bring it over here and make it the same size font so the equal signs line up, like so, here's year 3. So what happened is we took the value we got at the end of year 2, we plugged it into this equation, and here, which is really 1,210 times 1.1, 100% of the previous times 10% of that. So we now have $1,000 times 1.1 times 1.1 times 1.1, which comes out to be $1,331. So notice how it's accumulating more and more every year. And if we keep doing this, now we have year 4. Hello. I clicked on my arrow. Year 4. And I'm going to reduce this down so that the equal signs line up. Okay, so what we're doing now is we are taking our end of year 3 amount, substituting it in here and here and here like we did before, and if we take the previous amount and multiply it by 0.1, it's the same as taking the previous amount. When we add, that's 100%, and then 10% of that would be 110%, so 1,331 times 110%, which is the $1,000 times the 10% times the 10% times the 10%. Okay, that's these 3, and then this new one here goes, whoops, right here. And that's why they're accumulating. It's the 10% from each previous year accumulated. Okay, so now we get 1,464.10. And then year five, if I shrink this down so that they line up, okay, now year 5, we are taking our value from year 4. That's our 100%. 100% times 10% is 110%. So what we're doing now is taking this times this 1, 2, 3, 4, 5 times. So 1, 2, 3, 4, 5. And our final value is $1,610.51, not $1,500 like we got before without compounding. Okay, so now let's lead up to this new crazy equation. Okay, so the new equation is going to be our new value, n, is going to equal our previous value, p, times 100% of that plus our rate, r, times p. Oh, we already did the r. Okay. So, because we're going to distribute. So, if I take p times 1, that'll give me my p. P times r is right here, p times r. And so what I'm doing is I'm factoring out a p. I'm factoring out that 1,000. So n equals p times 1 plus r. And we're taking that to the power of how many years or time compounded. So our equation is n equals p times 1 plus r to the t. Hopefully you understand where that came from because I factored it out. So if I didn't factor, it would be n equals p plus r times p. So here's p, here's r, here's p. So that's where it came from. I can factor out a p because there's a common term p in both sides of this plus sign. So I factored out the p and got p times 1 plus r. And you take that whole thing to the power of how many years it's going to go by, because then we're going to multiply that by itself that number of times. So p times 1 plus r quantity to the t. Okay, so let's bring that in here. Let's get rid of this. And we're going to add that n. We're going to call that n instead of I now. Let's just put an n in here. Okay, so we have n equals p times 1 plus r to the power of t. So if I do 1 now with green, I'll have n equals 200 times 1 plus my r, which is 0.06, to the power of t, which is 1. So n would equal 200 times 1.06. So when I multiply that, 6 times 2 is 12. 2 times 0 is 0, plus 1 is 1. 2 times 1 is 2. Why am I using a 200? It's 5. This is 500. Let me just fix that. This is 500.061. I didn't catch that last time. Okay, it's 500. 500. So 5 times 6 is 30. 5 times 1 is 5. And that's the 530 we got. Okay, so as I said, the first year was correct, but now we're going to do the next years. Now I will do 2. Okay, so now we're going to do 2. N equals p times 1 plus r to the t. Now write this every time. Obviously it's a memorization process. N equals P times 1 plus 0.06 to the T, which is now 2. So N is going to equal 500 times 1.06 squared. Now don't forget your order of operations. You do the exponent first. 1.06 squared. Hey Siri, what's 1.06 squared?
1.06 raised to the second power is 1.1236.
So if I multiply that by 500, then it's 6 times 5 is 30. 5 times 3 is 15, carry the 1. 5 times 2 is 10, plus 1 is 11. 5 times 1 is 5, plus 1 is 6. And 5 times 1 is 5. I have 4 decimal places. That decimal is not in the right place. This should be here. Okay, and since we're talking about money, we only want to go out 2 decimal places. So it's $561.53. Okay, now let me just fix the error on that calculation. I have 2 zeros, so let me put a 0 here and a 0 there. 5 times 6 is 30. 5 times 3 is 15, plus 3 is 18. 5 times 2 is 10, plus 1 is 11. 5 times 1 is 5, plus 1 is 6. 5 times 1 is 5. I have 4 decimal places, so it's $561.80. Just get rid of these here. So that is what my N is after 2 years. Okay, so let's continue with that. So now we're going to do N equals, and if I use function notation, how about the new N of 5 this time equals 500 times 1 plus our R, 0.06, to the power of 5 this time. So that N of 5 is going to equal 500 times 1.06 to the 5th power. Hey Siri, what's 1.06 to the power of 5?
1.06 raised to the 5th power is 1.33822557776.
Okay, that goes way out. So if I multiply that by 500, okay, what will I get? Okay, I'm doing this off to the side here, so it comes out to be $669.11. Okay, now let's move on. N to the 10. N of 10 equals our P, 500, times 1 plus 0.06 to the power of 10. So N of 10 equals 500 times 1.06 to the 10th power. So N of 10 is going to equal 500 times, hey Siri, what's 1.06 to the 10th power?
1.06 raised to the 10th power is 1.79084769654285362176.
Okay, I'm not going to go out that far, of course, but when I do this and I multiply this times that, I get a because remember we're only going out to dollar values, so we only have to go out so far and then round. We're going to get $895.42. Okay, example 3. If you have $200 to invest, there's my P, for 10 years, that's my T. Would you rather invest your money in a bank that pays 7% simple interest or in a bank that pays 5% interest compounded annually? So the question is, do we want our rate to be 0.07 simple? Okay. Let's do this. Or 5% compounded. Now you might think initially be like, oh, 7% is more than 5%. I'm going to do the 7%. But watch what's going to happen. So we're going to either do 7 or 5%. So let me change colors with this so it's clearer. So this is simple. And let me just leave it. Yeah, that's fine. Simple. 0.07. All right. So now I'm just going to rewrite it again. Compounded. And that would be the principal still 200. The R is going to be 0.05. And the time is still going to be 10. So what is our simple equation? Do you remember? Where did we do it? Okay, so simple would be I of t equals principal times rate times time. Compounded is n equals p principal times 1 plus r to the t. Okay? So those are the two equations. So for the simple, we're going to say I of 10 equals the principal, $200, times the rate, 0.07, times the time, 10. So I of t is going to equal, well, 0.07 times 10 is 0.7, 200 times 0.7. So I of t is going to equal 1400 with one decimal place. So that would be $140 after 10 years. Because you'd be making $14 a year, so $140. So it would be the initial amount plus our $140 or $340. So if I took $200 and put it in a simple interest rate of 7%, after 10 years, I'd make $140 and I'd have $340. Now watch what happens over here. Take n equals our principal, 200, times 1 plus our rate of 0.05 times to the power of 10. So n equals 200 times 1.05 to the 10th power. And with help from Siri, what is Hey Siri, what is 1.05 to the 10th power?
1.05 raised to the 10th power is 1. 628894627774441406225.
Okay, she went way out further than I need to. So then I just doubled this. So how about I just, let's see, I only need a few decimal places. So 8 times 2 is 16. 8 times 2 is 16 plus 1 is 17. 2 times 2 is 4 plus 1 is 5. 2 times 6 is 12. And 2 times 1 is 2 plus 1 is 3. All right, so drum roll, please. Decimal place goes here, by the way. And that's an approximation too, so I could have gone out another one that may have rounded more, but we're looking at 325.76, so that would be 200 plus $325.76, which would be $525.76 after 10 years. So we made more interest than what we ended up with over here. That is a huge amount more. Oh wait, no, I don't want to add that. Disregard that last step. This formula includes so we don't add. So the amount is this. So the 7% simple was better than our compounded, but eventually there would come a time over a certain period of years where this would exceed that.